Hey guys, today we're going to do 6.4. You should get a classwork at the front of just where I keep all the classworks. Have somebody go up and get one and hand them out. Should look like this. Right underneath it, if you want, is the homework. You can get it now or you can get it after the video. It doesn't matter. Just don't start it until after the video, obviously. Um, but go ahead and take notes on all this stuff, and then once you're done, you can do the homework. So we have this warm up here. It's a free throw shot. It's actually the same equation we used earlier when we did quadratics. So we just kind of want to today kind of step away from rational functions specifically and just be able to interpret what's going on in graphs through the key characteristics. Today's more foundational, and the next class will be with application problems. So we have a free throw shot, negative 16 is the gravity, 24 is feet per second, the initial velocity that the basketball is being shot at, and then 7 would be initial height. So um, what you can do is use your graphing calculator, go ahead and graph it, and then try and answer these 6 questions here about what's going on in this scenario. And then when you're done with those, resume the video and we'll go over them. All right, so first question is how high does the ball get? So what I'm going to do is I'm going to go ahead and get this on my graphing calculator. So I'm going to have y equals negative 16x squared plus 24x plus 7. I'm trying to set a decent window, right? So x is t, which is measured in seconds, so 0 seconds. I mean, that's a basketball being shot. I can keep it at 10 seconds, but probably not much happening after, a few seconds. The y is the height, so I want 0 to be the ground, and then the basketball, I don't know, go a little higher than what I think it probably goes to. And then if I graph it, okay, that is the basketball being shot. So this is the height, this is the amount of seconds going by. So the first question was, how high does the ball get? Which I can do second trace, maximum, same stuff we did back in Unit 2. Whoops. Left bound says y, x is 5 right now, so y is really far down, so I'm going to go left. And I can see my y value is getting higher and higher, so it should start coming on the graph soon. There we go. And you go left of the maximum, right of the maximum, and enter. I get 0.75, 16. So 16 is the y, which stands for height. So the maximum height is 16 feet. And then how long does the ball take to hit the ground, right? So this basketball, because it's this height and it's this smooth curve, we're assuming it's not going to hit the rim. Otherwise, if it bounced around the rim, it would stay at, it would actually be at 10 feet for, a pretty long time. You'd see something happening right here. The fact that it just goes straight up and down tells you that there's nothing really, the height of the ball is not being influenced by anything. So it didn't probably hit the rim or anything like that. It was either an air ball or maybe even a perfect swish. So what I want to know is when the ball hits the ground. So that's going to be my 0 button. So left bound, I'm up here. I'm definitely to the left of the 0, or the x-intercept, same thing. So I can just go to the right now. And you can see it off the graph, but my y values are negative, so that means I'm to the right of it. So enter, enter, and I get 1.75. So it takes about 1.75 seconds for the ball to hit the ground in this case. What is the initial height of the basketball? That's 7, right? The initial height is when you plug in 0 for x or for t, right? 0 seconds, that means it's initial. So if I plugged in 0, I could get 7 on your calculator if you needed to do it. If you remember that second trace value, and I can type in x equals 0, and I get 7. But it's the same thing as plugging 0 in here, which you're going to get 7. This is just a visual representation of this. So we got 7 feet there. Where's the ball 7 seconds after it's released? So I can use the same button, second trace value, and I can hit x equals 7, and then I get negative 609. So, I mean, according to the graph, the answer is negative 609 feet. But this is kind of where this lesson comes into play and where it's going to go more next class. I mean, the ball's on the ground, right? At 7 seconds, the ball's on the ground. If anything, this graph, if it really was an air ball or something, would probably look like this, but then the basketball would probably go back up a little bit and go up a little bit and then up a little bit less. But at 7 seconds, it's probably just on the ground rolling. But these going up means the ball's bouncing, right? So it hits the ground, it'll bounce, bounce. I mean, it could get picked up by somebody and go back up to, whatever feet. But, for all we have is this, even though mathematically it's negative 609, we're saying 0, assuming nobody else touches it after it's shot, because keep in mind, common sense stuff is in play. So we'd probably say 0 feet right here. Over what intervals is the basketball increasing in height? Over what intervals is it decreasing in height? So if you looked at the graph, it's increasing from here to here, and then it's decreasing from here to here. And again, technically this is a parabola. It's going to go left forever, and it's going to go right forever. So you could say, negative infinity up to this point, and then this point down to, or right to infinity. But it's not, it's a basketball being shot. So there is no negative time, and there is no feet below ground. So we would say, we've got to figure out what that x-coordinate is of the maximum, which I had it before, but that's okay. We'll find the vertex, and when you describe increasing and decreasing, we do it in terms of the x-coordinates, which we'll do in a second after the slide too. So I need this x-coordinate right here, which you could do negative b over 2a and get it, but we have the calculator, might as well just do it this way. So we get, it's 0.75 exactly, actually. So it's 0 to 0.75 is where it's increasing. So we'd probably put it, and this is all interval notation, no brackets or anything like that, 0 to 0.75. So 0, 0.75 is where it's increasing. And then it's decreasing from this 0.75. So again, I'm just doing x-coordinates. 0.75 to right here, which we already found is 1.75. So 0.75 to 1.75. And that is where it's decreasing. And then the last thing is label each of these A, B, and C as a characteristic of a graph, right? And this is a quadratic, so how high does the ball get, right? That would be the maximum value, if you remember from Unit 2. So we have max value here. You could say vertex, but since it asks for how high, it's only the y-coordinate, so that'd be the max value. How long does the ball take to hit the ground? So what we found here, that was right there, that is what we call an x-intercept, or a 0, or a root. What is the initial height of the basketball, right? That we found is 7 feet, but the initial is right there. That is our y-intercept. So that's kind of what we're doing today, is looking at main characteristics of graphs, and then hopefully be able to compare graphs and see what we can find. But we do have these increasing and decreasing and constant intervals and graphs and stuff like this. So a graph is increasing if on any interval for any x sub 1, x sub 2, so just 2 x coordinates, and x sub 1 is less than x sub 2, which, I mean, if it's less than, it's to the left, right? So the first x, and this is the second x, this is left, and this is the one on the right, right? So for that interval, f of x sub 1, so it just means the y value where the first x is less than the y value where the second x is, right? So what does that mean? So like this part right here says increasing, so this must be right. So this would be x sub 1, it would be 2. And then x sub 2 would be here at 4, right? So f of x sub 1, so the y value right here, which is 1, is less than the y value here, which is 4, which is true, right? So what we see here is basically, this is a really complicated way of saying the graph is going up from left to right. You always read graphs from left to right. So left to right, the graph is going up. That means it's increasing. So when you describe the increasing interval, we use only the x-coordinates, right? The y's are going up, so that takes care of the word increasing. We're just going to describe it as the y's. So it's increasing from 2 until 4. So we do this in interval notation. Now it's decreasing, right? So we still have our decreasing interval for any x sub 1, x sub 2, right? And x sub 1 is still less than x sub 2, so it's to the left. So the first x is to the left, second x is to the right. Now the f of x sub 1, so the y value of the first x is greater than the y value of the second x. So here, the y value, this would be my first x. This would be my second x right here at 0. this y value is greater than here, which just means the graph is going down from left to right. So that would be a decreasing interval. So here it's decreasing from -2, which is the x-coordinate, to right here, which is at x equals 0. And then it's constant, right? So now just the y values are equal to each other, right there, y values equal to each other. That's where we say it's constant, so it's constant, again, looking at the x's from 0 to 2. And that would describe these ones. If we looked at this one kind of looks like it's constant in the middle, but if you think about it, it's x to the third, so even though it looks like it's almost constant, it's not. Like if you plugged in 0, you'd get 0 to the third, which is 0. And if you plugged in 0.1, you get 0.1 to the third, which is 0.001, but it's still slightly above 0. So this, even though it levels out, it is increasing. It's actually, again, read it from left to right, it's increasing the entire time. So that means negative infinity to infinity. And decreasing, you just put never, none, something like that, because it's never decreasing. Now, if you're saying, well, Mr. Johnson, it's going down, it must be decreasing, you're reading it from right to left, which is not how we read graphs. We always read from left to right, so it's always increasing. And then this one right here is increasing basically to right here. So this point right here, -1, 2, is called a relative maximum, which just means relative to the points around it. It's not the overall maximum, because the overall maximum is going to be infinity. But relative to the points around it, it is a maximum, which means this one right here is called a relative minimum. Relative to the points around it, it's the lowest. And at relative maximum and relative minimum is where the graph will change from increasing to decreasing, or from decreasing to increasing. So that's kind of something you want to know about. So this one's increasing from negative infinity, because there's an arrow, to -1, because we just used the x-coordinates. But there's also another section where it is, whoops. There's also another section where it is to infinity. I'm sorry. I did that right. To -1. There's also another section of increasing, which is right here after the relative minimum. So we're going to say union with, and then from 1 all the way to infinity, assuming these have arrows here. I got rid of it, but they do. So from 1 to infinity, and then it would be decreasing from here to here, which is just -1 to +1. And if you look at your answer, everything is covered. Right? You got negative infinity to -1. Here, -1 to 1, and then 1 to infinity. So everything's good. Now, if you had to do it on the calculator and you weren't given these points, you would just use left bound, right bound to get this max, left bound, right bound to get this min, and then you can do it that way. So you can use those buttons more than once for a graph. Okay. And then the other characteristic that might be new for us today is positive and negative position. Which is basically where your y value is positive and negative. And again, you describe it, you label it in interval notation with the x's, but you're looking at where the y's are positive. So if you think about this one, right, this is my x-axis. If it's above the x-axis, then all the y values are positive. So this one, even though it decreases and constant increasing, none of it matters for positive and negative position. The entire graph is above the x-axis, so all of the y values are positive. So this is positive position throughout. So again, do it with the x values, which is -2 to 4. And again, no brackets ever with this one either. And then there is no negative position, so you could just say none. This one's positive position. So where are the y values positive? Well, this is y is 0. And then all the way through here to here is where it's positive position. So we'd say it's positive from 0 to infinity. And then it's negative position, so below the x-axis, from negative infinity up until 0. So we're going to start with the lowest first. So we're describing the x values for these ones. This one, positive position, right? So here's where it starts and goes to 0. That's above the x-axis, but then also again over here, which, if you want to pause the video and try and figure out where these points are, it's a good question. So go ahead and try and do that. If you get stuck, just resume the video, or if you have an answer, resume the video. So positive position here, this answer right here is going to be negative root 3, and this one's positive root 3. This is a cubic, but you could factor out the x. Since they both have x in common, it leaves you with x squared minus 3. So you set each part equal to 0. This x equals 0 is this one. But then when you set this one equal to 0, you get negative root 3 and positive root 3. So those are your three zeros. So it's positive position. The changes where positive goes to negative are at the zeros, right? So positive from negative root 3 until 0, x equals 0. And then it's also positive again, so union with positive root 3 to infinity. And then negative position would be, basically this part here and this part here, because it's below the x-axis. So this would be negative infinity, those are the x's, to this negative root 3. Again, always parentheses, union with 0 to root 3. And again, if you look at your answer, you have every single section or interval of the graph accounted for, which is good. All right, moving on. So if you guys remember when we did processing partners, you had this word tabular, which just means expressed as a table. So this is an example right here. We don't have a graph to work with. We don't have an equation to work with that we could graph. We just have a table. So a little bit limited in information. We got, what about the coordinate of x equals 1? We don't have it. Okay, it may not exist, but it may. It's just that we don't have it in the data table, so that's it. So you think about intercepts. Basically, a y-intercept is where the x equals 0. So we have this. This is our y-intercept right here. And an x-intercept is where the y value is 0. So we do have one of them, which is right here at 11, 0. And again, could there be more? Maybe, but from the data, those are the only two that we can say for sure are intercepts. Increasing and decreasing, right? So you kind of want to look at the y coordinate and say, okay, are the y's going up? If they're going up, then it's increasing, right? So right here, we see increasing, right? It's 12, 18, 22, 24, 27. Okay, boom, down to 19. So it's increasing until we hit this point right here, which if you can kind of picture it, going up, going up, going up, going up, going up. Okay, after this, it starts going down. This is our relative maximum right here. So that actually answers this one right here. This is a relative max right there at 3, 27. So we're increasing from, again, we look at the x value, so negative 10 until we hit that max at 3. And we do include that in our increasing, just like we did before. And then we start going down after 327. So 27, 19, 7, 0, negative 5. And then wait a second, it bumps back up. Negative 5 to negative 4 is an increase. So this point right here is where it stops decreasing and goes back to increasing. So 15, negative 5 is our relative minimum, because it changes direction again right at the very end. So we do have another small section of increasing. We would include this right here, which is going to be 15, and then it only goes to 16 because it stops after that. So 15 to 16, it's actually increasing. And then decreasing would be, okay, this is 27, 19, 7, 5, negative 5. So it's decreasing in this window. So again, notice these numbers are going to be repeated. Those are maxes and minimums. So they're included on both. 3 to 15 is where it's decreasing. Positive and negative position. Just look at the y values. Where are they positive? Right? So y values are positive. Positive. It's going up, so it's definitely positive. Still positive. Still positive. Still positive. Even here, it's going down, but it's still positive. So we're okay. Okay, right here at our our x-intercept, or a 0, is where it's going to change from positive to negative, which is where our positive position will change from positive position to negative position. So it's positive position most of this data table. So it's negative 10 all the way until we hit 11 is where we hit 0. So we do include 11 for our x values. And then its negative position after that, it's like where the graph is going to cross the x-axis and then go down into negative. So negative position would be from 11 until 16, because that's all that we have. And that's how you would describe it if it was in the table. You really have to dissect the y column and then label it with the x's, right? So these are all x values that we wrote. And that takes care of that. So partner practice, if you have a partner who's kind of, you can do it with the people around you, or you can walk around and find someone. I don't care, but make sure you get this work done, because this is kind of the crux of the lesson. What I want you to do is find the intercepts increasing and decreasing, all of these main characteristics that we've just done for these. And for 1 and 4, I kind of want you to just, think about them. You don't have to write them all down, because obviously this one, negative position, boom, here, 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 here. I mean, it's going to take you a while to write them, but just kind of talk about it and say, okay, where's the negative position? Where's the positive position? Where are the intercepts? Where is it increasing and where is it decreasing? And then the same one with this one, which is going to look like it's a trigonometric graph. It'll just be very, very wavy, but think about those things as well. And then actually do 2 and 3 and label it with all of those things. So pause the video, go ahead and do those, and then start it back up when you're done. All right. So these one, like if we look at 2, hopefully we talked about number 1 and, increasing, 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 actually just increasing here. The rest is decreasing. You got some intercepts, intercept, that's a y and an x, intercept, intercept, I think you're okay. And then same with this one, you probably are okay. Just you probably know what you're doing with this. But here we have tabular representation of data. So this is decreasing. So from -5, it's decreasing. I'm sorry, increasing. Sorry. -114, -55. Still increasing. 2. Okay, this is where it starts to decrease. So -5 to -1 is increasing. Decreasing here, 2, 1, 0. And then it starts increasing again. So again, this would be a relative maximum. This would be a relative minimum. And then it increases again through the rest. Positive, negative positions a little easier. Negative position from, -5 to 1. And then positive position from 1 to 4. I think you guys are okay here. This one is a graph. I think you'd be able to graph it. Basically, it's a vertical asymptote at 3, which is what we've kind of already done. In fact, this +2 makes it a little bit different. Usually we'd say smaller degree on top than on bottom, so it's y = 0 as the horizontal asymptote. But this +2 is going to shift everything up 2. So now your horizontal asymptote is at 2. And then your graph just kind of has, make sure you don't touch the asymptotes, look like that. So when you think about, increasing and decreasing, it's actually always decreasing. Even though it jumps up, it's discontinuous. So like from left to right, it's decreasing, left to right, it's decreasing. So it's decreasing. You wouldn't say -infinity to infinity because of this asymptote. So you'd say -infinity to 3 and then union with 3 to infinity for decreasing. And then it never increases. Positive and negative position, you have to figure out what this intercept is first. So if you set the whole thing equal to 0, you could find the intercept here and then say, okay, if you subtracted 2, you get -2 equals 1 over x minus 3. And you can cross multiply, or you can just multiply both sides by x minus 3. So you get 1 equals, it's be -2x plus 6. And then subtract the 6, you get -5 is equal to -2x, and then you should get 5/2, right? X equals 5/2. That would be the intercept, so about 2.5, so it should be over a little bit, but whatever. So it would be positive position from -infinity to 2.5, and then union with 3 to infinity, because everything up here is positive. And then negative position just from 2.5 to 3. That's it. That's the one sliver where you're going to have negative position. And that's pretty much it. Okay. So you guys don't have to do much for partners anymore. What we want to do now is just compare things. So, take a minute, pause the video, and see if you can compare these three representations. And the way to compare them is to look at these things that we've already talked about, increasing and decreasing, max and min, intercepts, positive and negative, and see if you can come up with a conclusion based on all of those characteristics and what these graphs are. Okay, so if you found out the graphs are actually all the same exact thing, these points right here, -5, -4, they don't have y values, so they don't exist. And if you look at the graph, -5, -4, there's no values. It starts at -3, 4.7. Well, this is -3, yeah, about 4.7. Right? This graph is always decreasing. This one's always decreasing. And if you start looking at the y-intercept, 0, 2.1, 0, 2.1, okay, you start putting it all together. These are exactly the same thing. And then this one, see if this one's the same. This, if you remember from back in Unit 1, +3 on the inside means left 3 units. Plus 4.7 on the outside means up 4.7 units. So this is left 3, up 4.7. The negative means the square root is reflecting down, and the 1.5 just means it's being stretched. So you can start to figure out that, okay, this is actually the same thing as well. So these are all the same. And then same thing here, you can pause the video and see if you can compare this table with this graph. They're not the same thing. And then this graph with this table. See if you can come up with how these two are related and then these two are related. All right, so if you've taken some time to do that, you find, if anybody got it, good for you, this is actually a graph of e to the x. These are inverses of each other. Natural log of x, you could have graphed it. I would be okay with that if you use a graphing calculator. But natural log of x, like if I plugged in 1 for x, that would be 0, right? Anything where the argument's 1, it's 0. So this is, I plug in 1, I get 0. And if you look at the table, the only intercept you have is 0, 1. So, those are reverse coordinates. Natural log of e, right? If I plugged in e, which is about 2.7, natural log of e is equal to 1. We kind of know that from the log unit. So I get 2.7, comma 1. And if I look at my table, I have 1, 2.7, right? So these are flipped coordinates. These two graphs are actually inverses of each other, logarithm and exponential. And the base here is the base here, so they're actually perfect inverses. And then this one here, if you think about intercepts, right, I got -2, 0, 0, 0, 2, 0. Okay, what do I got here? I got -2, 0, that's the same. 0, 0, that's the same y-intercept and x-intercept. And then 2, 0, these are the same. Maybe the graphs are the same. But if you start looking further, this one's decreasing and then goes to increasing and then decreasing. This one, on the other hand, goes increasing, then goes to decreasing, then goes to, -2, 0 to 3. So now it turns to decreasing here, and then it starts increasing again. They kind of go in the opposite order. And then what you find is if you start looking at some of the coordinates, like -1, 3, -1, well, this is -3. This is actually a reflection over the x-axis. So the intercepts stay exactly the same, but all of these positive position is all negative position here. All of this negative position is positive position, and then same thing with over here. So it's just a reflection over the x-axis. And then here's your quick summarizer. You guys can do this on your own. Once you're done, you can start the homework. That's it.